Okay, so today's session is mostly about the discussion of the module exercise 1 and 2. So we'll start with exercise 1. Does anybody have a doubt in question 1 to 4? Question number 1 to 4 of exercise 1. Does anybody have a doubt? Please let me know. Otherwise, I will start with question number 5, which is the one I want to discuss. Okay. Atharva, I'll discuss question 3. Okay, so start with question 3 then. So I think it's page 37 if I'm not mistaken. Sorry, page 17 from your booklet. Let's start with question 3. It says that a displacement vector is at an angle of 30 degrees with the y-axis. Okay. So there's a displacement vector at 30 degrees to the y-axis. Okay. And it has an x component of 10 units. So we have to find the magnitude. We have to find the magnitude of the vector. So this is just about visualization. Okay. So you understand that this vector, if you place it in the xy plane, the vector should be such that its x component is positive and it's making a positive angle with the, it's making an angle with the positive y-axis of 30 degrees. So that means it can only lie in the first quadrant. If it was in second quadrant, then x component would have been negative. If it was in fourth quadrant, then the angle with the y-axis would have been an obtuse angle. So the only way it can satisfy this condition is that the vector is lying here somewhere. It's lying here somewhere such that this angle is 30, which means this angle is 60. And its x component is 10. Y component is something. Okay. So the x component will over here become magnitude of s cos 60, or we can also write that as magnitude of s sin 30, and that is given to us as 10. So the magnitude of the vector s is becoming 20 units. That becomes the answer. So this is question number 3. Okay. All right. Next, moving on to question number 5. So hope this is clear. So question. Okay, Anushka. So question 5 is asking the resultant of if the following vectors may be equal to 0. Okay, so the option A says that we have vectors of magnitude 10, 10 and 30. Suppose we have a vector A of magnitude 10. We have a vector B of magnitude 10 and a vector C of magnitude 30. It's asking, is it possible? Can A plus B plus C be equal to 0? The answer to that is no, because if this is the case, if A plus B plus C were to be 0, then C would be minus of A plus B. So that means magnitude of C would be equal to magnitude of the resultant of A and B. So that means that the magnitude of this should be less than equal to this. So if A is equal to 10 and B is equal to 10, so magnitude of C should be less than equal to 20, which means that C cannot be 30. Okay. So this is the logic for it. Okay. Another way of understanding the same thing is by geometry. The same logic that we've understood algebraically, we can express it geometrically also. You can understand it this way, that if A plus B plus C is 0, that means we draw the vectors A, B and C head to tail. Okay. And they should form a closed triangle. This is a condition for A plus B plus C to be 0. So you can see that in any triangle, in any closed triangle, okay, A equal to 10, B equal to 10, C equal to 30 is not possible, because the third side is greater than the sum of the other two. So this kind of situation is not possible. This is the condition for A plus B plus C to be 0. Think of them like displacement vectors. So they should form a closed polygon. So geometrically, A, B and C should form closed triangle when you draw them head to tail. So in that, this is not possible. Okay. Now let's look at the next part of this. Option B. It says that we have 4 vectors, okay, which are of magnitude 10, 20, 30 and 40. So we have so can so let us understand this algebraically. Okay. So if A plus B plus C plus D were to be equal to 0, okay, assume E plus B itself is some new resultant R, suppose. Then R plus C plus D would be equal to 0. Okay. Now R's magnitude which is equal to A plus B's magnitude would have to be less than equal to magnitude of A plus magnitude of B. Okay. So therefore, if A's magnitude is equal to 10 and B's magnitude is equal to 20, then magnitude of R would have to be less than equal to 30. Okay. So this is my statement 1. And R plus C plus D equals to 0. This implies that D, for example, is minus of R plus C. So D's magnitude is equal to magnitude of R plus C. Okay. So that again in turn implies that magnitude of D equal to magnitude of R plus C is less than equal to magnitude of R plus magnitude, okay, or D has a magnitude of less than equal to R plus C. So this is my second statement. Okay. Now let's put together the two statements that we have. So if A is equal to 10, B is equal to 20, C is equal to 30, D is equal to 40, then the first thing we had was that R is less than equal to 30. So the first statement. So now substitute that here. So that means D should be less than equal to 30 plus 30, or D should have a magnitude of less than equal to 60. Okay. Therefore, E can be. So E plus B plus C plus D may be or can be 0. So this is the way of doing this question logically or algebraically. Okay, just go through this once. So we are applying the triangle law successively twice over here. So this is also an important variation of how to apply inequality. But we'll also discuss another way of understanding this geometrically also. So hope this question is clear, people. Okay, so now let's try to understand this question geometrically. First of all, make sure this solution is clear to all of you. So geometrically, okay, if A plus B plus C plus D is equal to 0 and A, B, C and D are coplanar vectors, then the condition for the resultant to be 0 is that, just think of them like displacements. So if we started from some point like this over here, from some origin, the resultant of, suppose the vector E starts from the origin, then the vector B, suppose from the origin you reached A's head, so B takes you, let's say, somewhere here. Okay. Then C takes you, let's say, somewhere from the head of B. C takes you somewhere here, let's say. then finally for your resultant to be 0, D must take you back to where you started from. So that means D must be the fourth and final side of a quadrilateral. So the condition for A plus B plus C plus B to be 0 must be that if drawn head to tail, okay, vectors A, B, C and D must form the four sides of a closed quadrilateral. So the magnitude of D must be less than equal to A plus B plus C. Okay. Therefore, A equal to 10, B equal to 20, C equal to 30, D can be 40. Okay. So this is the way of understanding this geometrically. Provided I am applying the condition that they are coplanar vectors. Therefore, we can draw them in a two-dimensional plane. Okay. Also, you can see the way we have done it logically. We have just introduced an extra vector in between over here, which was the sum of A and B. That was this. So you can see that we were applying triangle law twice by involving this. We also saw that once there was this triangle, that R is equal to A plus B, and then there was this second triangle, this one, where we said that D is equal to minus of R plus C. We applied triangle inequality twice. So that was also another way of understanding the same question. Okay, so hope this is also clear. Now the next thing you have to understand is that, is it possible, I mean, though the question is done, but just think of this logically and tell me. If the sum of four vectors is equal to 0, is it necessary that they must be coplanar? Just think of this question and tell me. Just think for this for a bit and tell me the answer, yes or no. Is it necessary that they have to be coplanar? Correct, Varun. Varun, your answer is correct. Yes, Hitansh, correct. Siddhi, correct. Naman, correct. Pratinav, correct. Arnav, correct. What about others? Okay, so as it turns out that no, it is not necessary. The answer is no. Because just imagine a quadrilateral folded by some angle about one of its diagonals. Okay, so just imagine this situation. You have a quadrilateral, any arbitrary quadrilateral, and now what you do is you fold it about one of these diagonals. So if you fold it, it becomes a non-planar figure. So now if you consider sides as vectors, okay, so its sides would be represented as non-coplanar lines, or you can convert them into vectors such that the resultant is still 0. So that's possible. So that is why non-coplanar vectors, 4 of them, can give you a resultant of 0. So it's not necessary. Okay. So 4 vectors can be non-coplanar and such that their resultant is equal to 0. But still, the vector D must have a magnitude which is less than equal to the magnitude of A plus B plus C. If this condition still holds, because it's still the same figure of the quadrilateral, so the relationship between the magnitude of the sides still holds. Just because you folded it about one of the diagonals, it doesn't change the relationship between the magnitude of the sides. Okay, so hope you understood this question, people. Okay, now similarly, if you come to the option C, okay, of question 5, you will see it is not possible, because so coming to option C, the same question, there it is given that magnitudes are 10, sorry, 5, 10, 20 and 40. So you can see that magnitude of D should be less than equal to magnitude of E plus B plus C. So from this, magnitude of D should have been less than equal to 35. So therefore this is not possible. Therefore cannot be 0. Same logic, but anybody have a doubt in question 6? Please let me know, people. Does anybody have a doubt in question 6? Okay, so we will discuss. So question 6 is saying that we have 3 vectors such that magnitudes of the vectors are 1, 2 and 3, and the vectors lie along the consecutive sides of an equilateral triangle. Okay, in order. So we have to find the magnitude of the resultant, and also in 7th question we have to find the angle of the resultant with respect to the vector E. So this is 6th and 7th. So anyway, let's understand the language of the question. So what it is saying is that if we have some kind of an equilateral triangle, then vectors A, B and C lie along the sides but are of different magnitudes. So let's say this is vector E, suppose, lying along the first side, but its magnitude is unity. Then comparatively vector V is lying along this side, but its magnitude is not the same, it's 2 units. And comparatively vector C is lying along the third consecutive side like this, and its magnitude is 3 units. So what it's telling you is that the relationship between the vectors in terms of angles is like this. This angle must be 120 degrees. This angle must be 120 degrees. And this angle must be 120 degrees. So what it is saying is that basically E, B and C are coplanar vectors such that the vector B is at 120 degrees to A and C is at 120 degrees to B. Both I have taken to be anti-clockwise angles, and okay, like this. So one way we can use component algebra. Okay. So method 1 is component algebra. So in that we can just assume that we take our x-axis along the vector A to make things convenient. Okay. So the vector E will very simply become just I cap, because it's having a magnitude of unity, and I'm taking my x-axis along the vector E. So E is of magnitude 1 unit. So make this a little smaller so it's easier to draw the other vectors. Okay, now in comparison, B will become a vector. Okay, now in comparison, B will be a vector which is at 120 degrees but of magnitude 2 units. Somewhere here, let's say. this angle will be 120. And in comparison to these two, now the vector C will be in the third quadrant, like this. And its magnitude will be 3 units. More importantly, this angle will be 120, which also means that you can figure out that this angle here will be 60. So we can see that the vector E will be equal to I cap, the vector B in component form, magnitude 2 and angle 120. So cos 120 you know is minus half. So it will become minus I cap, and sin 120 is plus root 3 by 2. So plus root 3. Okay. And similarly, the vector C will have an angle with the x-axis which is 180 plus 60 or 240. So its x component will be minus half times 3. So minus 3 by 2 I cap. And its y component will become minus root 3 by 2 times 3. So it will become minus 3 root 3 by 2. So now we can see that the resultant will be equal to 1 minus 1 minus 3 by 2 and 0 plus root 3 minus 3 by 2 times root 3 j cap. So we can see that the resultant will be this vector. It will be minus 3 by 2 I cap minus root 3 by 2. So once we got this, now we can find out its magnitude and the angle with respect to the x-axis. So just note down this much first, then we'll do the calculations for resultant and angle. No, it will not be. It is 1 minus root 3 by 2. No? This factor it is root 3 into 1 minus 3 by 2. So it is into minus. Okay, Varun, is it clear? Okay, so now let us understand that magnitude of the resultant becomes square root of 3 by 2 ka whole square plus root 3 by 2 ka whole square. So that is square root of 9 plus 3 by 4. So that will become root 3. So that is the answer to the 6th question. And also you can see that how the resultant is looking in comparison to the vector E. So the vector E was I cap like this along the x-axis. So the vector r is where it is somewhere here now. It's having negative x component and negative y component. So it is something like this. Minus 3 by 2. And this is minus root 3 by 2. Okay. So we want to now calculate which angle? We want to calculate this whole angle. We want to calculate how much this is with respect to the vector t. So for that, we can start by calculating this angle. You can see that tan alpha is this side divided by this side. So root 3 by 2 divided by 3 by 2, or 1 by root 3. Okay. That means alpha is equal to 30 degrees. So theta will become how much? It will become 180 minus 30. Theta will become 150 degrees with respect to the vector t. Okay. So this is question 7 answer. Yeah, we can also express it as 210, okay, because two vectors which are like this angle is 210. So this angle is 150. You can also see it this way, that with respect to positive x-axis, okay, r is at theta equal to tan inverse 1 by root 3, but in quadrant 3, so theta is equal to 180 plus 30, so 210. So this would be your theta, the anti-clockwise theta. But since we are expressing the angle between two vectors, we don't have to give the angle as anti-clockwise. We can also give it as clockwise without changing the sign. It's an anti-clockwise angle of this thing. So it's same as clockwise of 150. Have you understood the difference of the two, Amo? If I said with respect to x-axis with proper sign convention, then yes, I should say it is 210 or minus 150. If I am saying as my 150, it should be with minus sign. But since here I am talking about the angle between two vectors, तो मुझे sign convention use करने की जरूरत नहीं है. I should always give the smaller of the two angles. Is the point clear, Amo? Oh, good. Okay, now we can also do this question geometrically. Let's understand how. So second method, geometrical method. So A plus B plus C is equal to R. So draw the vectors A, B and C head to tail. So the resultant will be the vector from origin, that is tail of the first vector E, to the head of the third vector C. So let's understand how that will work out. So we had seen earlier that our vectors were actually like this. This was the vector E. In comparison, the vector B was like this. In comparison, the vector C was something like this. Magnitude 1, 2 and 3. This angle was 120. This angle was 120. So now let us draw them in this way so that we can find this out. So to draw them this way, we'll have to make a figure like this, where this is our first vector. See E. So magnitude 1 unit. Then in comparison, our vector B will be like this. Magnitude 2 units. And vector C now will be like this. Of magnitude 3 units. And also, you can see that this angle is 120 degrees. And also we can see that this angle is 120 degrees. Okay. Now in this diagram, what is the resultant? The resultant is going to be this particular vector. The resultant will be from the origin of A to the head of C. It's like, think of 3 displacement vectors. So you made a displacement of A, you reached here, then B, then C. So your final position is here and your origin was here. So it will be from the origin of O to the head of C. So this will be the resultant of E plus B plus C. This point. From the origin of O to the head of the final vector, that will become the resultant. So the thing is, can we make use of geometry? So we want to find out magnitude of R, okay, and theta with respect to the vector E. These two things we want to find out. So how do we do that? So we can make use of geometry. See, the fact that these two angles are 120 means that this angle is 60. This angle is 60. So now the clever thing we can do is, if we just extend this line, you can see that this figure is an equilateral triangle. Okay. So next what we can do is, we can understand that the quadrilateral formed by the vectors E, B, C and their resultant R, okay, it can be broken into an equilateral triangle plus an isosceles triangle. So let's see how that's happening. In the above diagram, Something like this was happening. This was the origin of the vector E. This angle was 60. This vector was B. And this whole thing was C. So this was 3 units, this was 2 units, this was 1 unit. And this was just a dotted line. So because this angle was also 60, so therefore this angle became 60. So now you can see that this is our equilateral triangle. This one is our equilateral triangle. And because this is equilateral, therefore this side will be 2. And this whole side will be 2, which means this side will be 1. Because E's magnitude was 1, so the remaining this has to be 1 because it has to be an equilateral triangle. So now that also means that because the vector C had a magnitude of 3, so therefore this side will have to be 1. This side will have to be 1 unit. So that is why this one is now becoming an isosceles triangle. Two sides are equal. Okay. And if you remember now, this is what we have to calculate. This R is what we have to calculate. Because A, B, and C are already known. So now make use of the geometry of that isosceles triangle. So pick up that isosceles triangle and understand its geometry. So that isosceles triangle from above, you can see this side is 1 unit, this side is 1 unit, this side we have to calculate. And we also know that this angle here is 60 degrees. Okay. Now see the interesting thing here. Just use the property of isosceles triangle. So this side is equal to this side. Therefore, this angle, suppose is alpha, this angle will also be alpha. Okay. And the sum of these two should be equal to the opposite angle, opposite exterior. So alpha plus alpha should be equal to 60 degrees, which means that alpha is equal to 30 degrees. That's the first one. Okay. So if alpha is 30, then we also know this angle which we are looking for. The angle with respect to A, that was this theta. So theta is equal to 150 degrees. So this is question 7's answer becomes. And the other thing we can do is we can use the property of isosceles triangle that if you drop a perpendicular from the vertex onto the equal side, onto the third side, then it bisects this. So if we drop this perpendicular, yeah, we can do supplementary angle also, that's fine. One in the same thing, that's correct. If you bisect this, you will get two identical right angle triangles where this side is x, so this side should also be x. So we take this as x, then this should also be x. We can see magnitude of r is equal to 2x And here we can see x upon hypotenuse. So x upon 1 unit is equal to cos of the angle. So x is equal to 1 into cos 30. So x is equal to root 3 by 2 unit. Therefore, magnitude of r will become twice of x, or root 3 by 2. So that becomes the answer to question 6. So this is a very interesting geometrical solution of it. It's coming because there is some kind of symmetry in the question. So we are able to make use of that symmetry and draw this quadrilateral, which is easily working out to be the sum of two useful triangles, one an equilateral triangle and the other an isosceles triangle. So as I told you, the geometrical method not always works. If these were more random vectors, then we wouldn't have found any symmetry like this, and it would be geometrically very difficult to calculate. But because they are having a certain kind of symmetry, that their angles with respect to each other are 120 and they are of magnitudes 1, 2 and 3, we are able to do this geometrical solution also. So the general method is always the component algebra. That will work whether or not there is any symmetry. But whenever a question has some kind of symmetry to it, then sometimes we come up with a very interesting geometrical solution also. And that is the second method over here. So just make a note of this, people. We will continue then. And also ask me if there's any doubt. So yes, ask me, your point is correct. We could have taken the supplementary angle also over there. So the triangle, the isosceles triangles unequal angle would have been 120. So the sum of 2 alpha would have been 180 minus 120, and that's how we would have got alpha also. Okay, so next up, does anybody have a doubt in question 8th or 9th? Question 8 or question 9, does anybody have a doubt? Okay, that's good. I think they are simple questions. So in 8th, you have to just find dot product of force and displacement. That will give you work done. So that's a simple question. And in 9th, you can just do it by cross product or logically. Either way, it's simple. Okay. 10th question, 9th. Okay, good. So in 9th question, Vineet, I'll explain to you. तो क्या करना है देखो, vectors A and B कैसे हैं? They are lying in the xy plane, right Vineet? Because one is I cap plus j cap and the other is I cap minus j cap. So what is the direction perpendicular to both A and B? So A and B are lying in the xy plane. So the direction perpendicular is what? It is the z axis. Okay. So the vector C should lie either along the positive z axis or along the negative z axis. So there are only two possible values of vector C: plus 3 k cap or minus 3 k cap. Is it clear, beta? So question 9. Okay. Good. So in question 9, the vectors A and B are in the xy plane. That you can see from the way they are given. So therefore, C perpendicular to A and B, that implies that C is along Z axis or Z prime axis, whichever. Okay. And magnitude of C is given to us as 3. So that means C can either be plus or minus of 3 k cap. Now one of the two options is given to you. Okay, so what about 10th question? I think 10th is an interesting question, so we can discuss once. 3D geometry. Okay, so let's come to 10th question once. So it says that vector E okay, I'll come to question 21. Points downwards. So you can say it points along gravity, along the gravity vector, whereas B points eastward. Okay. So direction of A cross B, ये अपने को निकालना है, calculate this. Okay. So you have to imagine this in 3D. That suppose we have a horizontal plane which is looking like this. This is actually our horizontal plane. So acceleration due to gravity is pointing into the plane, like this, into the plane. So this is our vertical axis. Vertical. Cutting through the plane and going down like this. So in this plane now, our north-south direction is this, and our east-west direction is this. So let us take this as northwards. So this is our y-axis. Let us take this as eastwards. So this is our x-axis, and therefore let us take vertically upwards will become our z-axis. So our vector E will have what sort of direction? Vertically downwards. So vector E will be minus E k cap, whereas vector B will be B I cap. Okay, this is eastwards, and this is okay. As we understood. Okay, don't worry. I'm coming to your doubts very soon. Vertically downwards. Okay. So you can see that the direction of A cross B will be given by minus E k cap cross B I cap. So that is minus EB into K cross I. Now remember, K cross I is how much? It is G. So this cross product of the two units vectors will be replaced with G. So the direction of this becomes along minus J cap, and minus J cap is what? Southwards. Okay. So this is along minus J cap or southwards, pointing south. Okay. So this same thing you can also understand by physically doing the cross product using your right hand thumb rule. So if the vector A is pointing vertically downwards like this and B is pointing eastwards like this, okay. So you can see that your thumb pointing down and your fingers pointing in this direction. Okay. You see that your palm is facing this way, just like this. Palm is facing this way. So this will be your direction of south. Exactly, Snikita. We can also use the right hand palm rule. Okay, so next, does anybody have a doubt in questions 11 to 15? I have not received a request for any of these questions yet. Question 11 to 15, any doubts? Please let me know on the text. Otherwise, I will proceed with question 16. Okay. 13 and 14 we'll discuss. Okay, okay. Direction 11, so we'll discuss all 11, 12, 13, 14. Okay, so let's come to question 11 next. So the problem is with the direction in 11th, and I'll explain very soon how to resolve the question. So in question 11, what is happening is that particle is moving eastwards and changes direction to northwards in 10 seconds. Okay. So the initial velocity, if you take this as a north, south, east, west direction. So initial velocity is towards east. This is our initial velocity vector. This is towards east, and it's 5 meters per second. And then it changes its direction towards north. So our final velocity vector is this. And its final velocity is also 5 meters per second, but is pointing northwards. So what will be a change in velocity? It will be final minus initial. So that will become this. This will be our delta V. So you can see it will be V root 2 or 5 root 2 towards which direction? This will be 45. Okay. So it will be towards northwest. Okay. So that is why our average acceleration, which will be change in velocity upon change in time, will be equal to 5 root 2 meters per second divided by 10 seconds or whatever towards northwest. Okay. You can also do by triangle law. Here I have done by parallelogram law. So I have taken the two vectors. Suppose this is A and this is B. Then this is a square actually. So this diagonal becomes A minus B. Have you used this method? Or you can also do like this, that A plus of minus B. Because if this is B, then this one is minus B. So this is A minus B. You can also do it by triangle law, like this. Okay, so hope this is clear. Now let's come to 12th question. 12th is also actually a very interesting question. So question 12 says that there are 5 forces of equal magnitude acting at a point such that they lie in a common plane. Okay. And the angle between any two consecutive vectors, or in this case consecutive forces, is equal. So you have to find the resultant. So first of all, let's understand what the question is saying. So it's saying that if we have some kind of a point, then 5 forces are acting at that point. So let's say they are represented by these vectors. So let us say this is some kind of a particle or a point, whatever, and this is one of the forces acting on it, F1. So now there are 4 other forces, 5 in all, which are coplanar. So they are all lying in this plane, but such that they are of same magnitude and the angle between two consecutive forces is the same. So this is F2 is the same magnitude as F1. This is F3 is the same magnitude. This is F4 is the same magnitude. And it is F5 is also the same magnitude. Okay. So all these 5 vectors are of identical magnitude, and not only that, the angle between consecutive ones is the same. Okay. So this angle is the same as this angle, is the same as this angle, is the same as this, is the same as this. So you can see that magnitude of F1 is equal to magnitude of F2, is equal to 3, is equal to 4, is equal to 5. And that theta is the same for all of them, so it is 360 divided by 5, or 72 degrees. Okay. So then we have to find the resultant of these. Okay. Now it's very difficult to do this by component algebra because we don't know how to calculate cos 72, sin 72, okay, or cos 144, sin 144. So we'll have to use a calculator and all that. So better than that is use geometry. So let's understand this geometrically. Okay. Now it will strike you that geometrically this angle 72 comes where? It comes in the case of a pentagon, a regular pentagon. If you draw regular pentagon you can try doing a better job than me of it, but anyway. So if you see a regular pentagon geometry, it has that interesting feature that draw the centroid and join all the vertices to the centroid. So because these sides are all equal, so what will happen? These angles will all be equal. Because they're equal, they will be 360 by 5 or 72 degrees. Okay. And now because each of the triangles formed by the centroid with the sides are isosceles triangles, because this side is equal to this side. So these angles are all equal. So alpha is equal to 180 minus theta ka half. Okay. Therefore, now all the exterior angles again become theta, because you can see theta is 180 minus 2 alpha. The exterior angle between two consecutive sides is again 72. Okay, so the regular pentagon has these two important features. One is the angle subtended by any side on the centroid. Centroid is this point, C, let's say, is theta equal to 360 by 5 or 72 degrees. That's one point. Okay. And therefore, you can see by using geometry along with this fact, the angles between, so actually the exterior angles, the exterior angle between any two consecutive sides is also theta equal to 7. So just make a note of this fact first about the regular pentagon, and then we will see how we can connect this concept with the question we have in hand. which is about the 5 vectors. Now you can see how we can connect question 12 with this concept and try and come up with a solution. Okay, so no, so Varun, we have to give some concrete logic why the forces are cancelling each other, no? Because there are 5 forces. Had there been 6, we could have seen there, just some of them are opposite and all that. We could have cancelled in pairs. But here they are not cancelling in pairs. So now we can see that if we draw the 5 forces head to tail, we draw the 5 forces head to tail, they will look exactly like the sides of that regular pentagon. Try and do a better job of this. Easy actually. So you see that this is how the 5 forces are looking. F1 is at 72 degrees with respect to F2, which is at 72 degrees with respect to F3. Again at 72 degrees with respect to F4. It's again 72 degrees, and they are all of equal magnitude and they are coplanar. So because F1's magnitude is equal to F2's magnitude is equal to 4 and 5, and theta is equal to 72 degrees between F1 and F2 and F3, and so on and so forth. Okay. Therefore, when drawn head to tail, the 5 forces form a closed polygon. Which in this case is a regular pentagon. Therefore, the resultant is equal to 0. In the case of odd number of vectors like this, this becomes necessary to prove like this. In case of even number of vectors, you will see that they cancel in pairs, but here they are not cancelling in pairs. Had there been 6 vectors each at 60 degrees to each other, you would have seen in pairs they cancel each other. But in that case, they would have formed a regular hexagon. So hope the concept is clear to all of you people. Okay, next moving on to question 13, which also 3 students have asked. 13 is very similar to a question we've discussed earlier in our worksheet also. So I'll go through it quickly. Okay, so question 13 is about the relationship between velocity and displacement actually. 13 is saying that a particle starts from a point P at time t equal to 0, okay, which is given by the coordinates 1, 0, 0, but moving directly towards another point B, which has a coordinates 4, 4, 12. Okay. So because it is moving towards B, so we will see that its direction of motion is along this line. So let's say this is some vector which is the displacement from A to B. So its velocity vector should be directed along that line because it's moving directly from A towards B with a uniform velocity. So it's moving with a uniform velocity which has a magnitude of 65 meters per second. Now, at some other time, it crosses the point D and let's say reaches some point P or C or whatever, X, Y, Z at time t equal to 2 seconds. So we have to find out what this X, Y, Z is. Started from here at t equal to 0 from E and it's reached all the way to this new point C. So we have to find its coordinates. Given this information that the magnitude of its velocity is 65 meters per second and direction is along that A to B or that displacement vector from A to B. So how we'll do this question? We'll use the concept of unit vector like we've seen earlier. Okay. So we'll use the concept of unit vector and we'll see how that works out. So we'll see that because velocity is along that displacement vector EB, therefore we can say velocity is along a unit vector, let's say n cap, where that n cap is nothing but the displacement vector EB divided by its own magnitude. Okay. So now A is the point 1, 0, 0. B is the point 4, 4, 12. So what is the displacement from A to B? Just a moment, guys. I'll restart my whiteboard program. Just give me a moment. So my displacement vector from A to B, okay, that one will be along the x-axis. I'm going from 1 to 4, so 4 minus 1 I cap, plus along the y-axis I'm going from 0 to 4, along the z-axis from 0 to 12. So it is 3 I cap plus 4 j cap plus 12. Okay, so this is the displacement from A to B. So what about the unit vector now? This one. This unit vector will become this displacement divided by its own magnitude. So it will become the displacement divided by square root of x square plus y square plus z square. Okay. Now you can see that that will be 9 plus 16 plus 144. That is So n cap is this unit vector. So the velocity is along n cap, and the magnitude of the velocity is 65 meters per second. So now we can write velocity as a vector. So it is this unit vector multiplied by magnitude of 65 meters per second. So now just use ordinary algebra. So the velocity becomes, if we take the 5 inside, it has an x component of 15 meters per second, a y component of 20 meters per second, and a z component of 60 meters per second. So this is the velocity. Okay. Now we only done half the problem so far. We still have to find the location of that point C. So I'm coming to that. So now what we've done is we've found out what this velocity vector is. Okay. But we still have to find the coordinates of this point C. But we know when it is reaching the point C. It is reaching at the time 2 seconds. Okay. So we know the displacement in 2 seconds because we know the velocity. So now we know that, therefore, the displacement from A to C is nothing but the displacement in t equal to 2 seconds. Okay, so that is nothing but velocity multiplied by time. So it is nothing but 15 I cap plus 20 J cap plus 60 K cap in meters per second, okay, multiplied by the time of 2 in seconds. So that displacement is 30 I cap plus 40 J cap plus 120 K cap in meters. This is the displacement from A to C. Now A is the point 1, 0, 0. So C is the point x, y, z, which we have to find out. So x will become how much? It is going from 1 to a displacement of 30 I cap. So 1 plus 30, that will become 31. It is going from the y coordinate 0 to a displacement of 40 j cap. So y coordinate will become 40. And is going from a z coordinate of 0 to a final z coordinate where the displacement is 120. So it's 120. So that final point C will become 31, 40, 120 meters. That will be the location of the point at t equal to 2 seconds. This is the position. Okay. So it is making use of the concept that displacement is equal to velocity into time. Okay. So once we are using this in the fact that velocity is along the unit vector n cap, which will be displacement divided by its magnitude. And second time, we are also making use of the fact that displacement is equal to velocity into time. So we are calculating the velocity vector, multiplying it with time, and then finding the final coordinates. Okay, so just make a proper note of this, people. This is question number 13. Okay, people, so hope this is clear. Now moving on to 14th question. Quite an easy question. Question 14 is saying that you have three forces proportionate to sides EB, BC and 2 times CA of triangle ABC. So resultant is out. Okay. So let's just draw an arbitrary triangle and understand what this means. Suppose I just have some odd triangle like this. ABC. Now I can represent the force F1 as, let's say, the vector AB, the force F2 as the vector from B to C, but the force F3 will have to be twice of the vector C. So that means in this diagram, the force F1 will be like this. The force F2 will be like this. But what about the force F3? The force F3 will become a little different. It will become double of this third side. It will be like this. Just to show it. The force F3 is like this. F3 is twice of C. So now you see what is your resultant. Your resultant is going to become from the origin of your first force, which is this point E, to the head of the last force, which is this point. So your resultant force is going to become this. It's going to be F1 plus F2 plus F3. So you can see that this will actually become F3 by 2, which is basically equal to C. So it's proportional to the side C. Why? Because you just break this up. It is EB plus BC plus twice of C. So that is EB plus BC plus CA plus C. Now you can see that this is going to be 0 plus C, because it's forming a closed triangle. So that resultant is 0. So that becomes your answer. So hope this is clear, people. That's question 14. Moving on to question 15. Okay, so next thing, question 15. It says that you have two forces which are of magnitude 3p and 2p, and their resultant is r. So F1 has a magnitude of 3p, F2 has a magnitude of 2p. Suppose the angle between them, between F1 and F2, is suppose theta, then resultant of them, okay, will become such that F1 square plus F2 square plus 2 times F1 F2 cos theta. Okay. So R will become P into square root of 9 plus 4 plus 12 cos theta. That is, let's say, equation 1. Okay. Now it says that if F1 is doubled, then its resultant with F2 also is double of R. So let us say F1 is doubled. So 2F1, it will have a magnitude of 6p. Okay. And F2 has a magnitude of 2p already, you see. Okay. But then what is happening? The angle between 2F1 and F2, that is still theta only. Okay. So if the resultant of these two is now R prime, okay, so this resultant will have a magnitude of this much. Now this resultant should be twice of the earlier resultant. So that should be equal to p into square root of 36 plus 4 plus 24 cos theta. So this is your equation 2. Now if you solve equation 1 and 2, you will get the required answer. So solving equation 1 and 2, one that we have written earlier, you will get cos theta as minus half. That means theta will be equal to 120 degrees. So this is the solution of question 15. You have to just do the solving part which I have left out for you. You can do yourself. Okay. let's move on to question 16. So question 16 is saying that three forces create equilibrium at a point. So equilibrium का मतलब क्या होता है? That the resultant force should be zero. That is, the resultant net force, okay, that quantity is equal to zero. That is the meaning of equilibrium. Now the resultant net force of what? Of, in this case, three forces, P, Q and R is zero. So that means P plus Q plus R का vector sum कितना है? Zero. Okay. And they are at an angle of 120. P and Q are at 120 degrees. Q and R are at 150 degrees. So we can interpret this in two ways. Okay. One is that if you draw P, Q and R head to tail, you will see that they have to form a shape like this. They have to form a closed triangle. Now, this angle is 120 and this angle is 150. Okay. So that now means that before that, this is your vector R. So that now also means that this angle is 60. This angle is 30. So that means that this angle has to be 90. Okay. So that is the case. You can see that P upon Q is cos 60 or 1 by 2 and R upon Q is sin 60 or root 3 by 2. So therefore you can see that P is to Q is to R will become 1 is to 2 is to. This is the easy way of solving this. So this is, in this case, the easy way of solving it because the triangle worked out to be a right angle triangle. Okay. Otherwise, we can also do this by component method. By component method, what you can do is you can take some random xy axis such that imagine your vector P is along the x-axis. Some Pi cap. Now in comparison, the vector Q will have to be at 120 degrees to this. So if this angle is 120, the vector Q will have to become minus Q by 2 I cap plus root 3 by 2 Q J cap. And finally your vector R will have to be at this. Why it will have to be like this is because this angle is given to us as 150. So that makes it this. 120 plus 150 is 270. So R will have to be minus R j cap. And of course the vector p is this. So now you just have to apply the condition that p plus q plus r is 0. That will imply that capital P minus q by 2 plus 0 I cap plus 0 plus root 3 by 2 q minus r j cap. This is a null vector. So that in turn just tell you that p minus q by 2 is 0 and root 3 by 2 q minus r is 0. That is p by q is 1 by 2 and q by r is 2 by 2. So this again gives you the same condition. अच्छा तो फिर उल्टा कर लो उसको. If the angle is reversed, just take it reverse. Okay, but you will get the same solution. So if this is 150, then again this is okay. So just the components will change a little. So you will get a similar kind of answer, but so if that's the case, then it will be like this. This is P. This one will be 150, and this one will be 120. But this angle will still be 90. Now this will be 30, and this will be 60. Okay, Vaishnavi, hope this is clear. Okay, Pratinav, you might just have to click on the shared screen thing again. Just go to the options of the windows, the different windows available on your screen, and click on the shared screen. Double click on it, you will get the shared screen. Okay, now, okay, good. Now 17, 18, 19, 20 should be easy. Try these out yourself. Okay, we will just as a practice of what we've done last time, we will find out the answer of question 21. Okay, so we will conclude with question 21 today because it is a projection type of question. So the vector E is given to us as 1, 2, 2. So I cap plus 2j cap plus 2k cap, and the vector B is given as 2, 1, 2. 2y cap plus j cap plus 2k cap. Now we have to find the projection of vector B on E. So projection of B on E, it means along vector E, like that. We निकालना ना B on A or E on B on A. Okay. So it's basically like this only. You imagine that if this is your vector E, and this is your vector B, and you drop this perpendicular here. So this becomes the projection of B on E, let's say B parallel. So that has a magnitude of B cos theta, but its direction is along the vector E, so it's E cap. So this thing as a vector, expressed as a vector, so that will be B cos theta A cap, okay, where B cos theta can express as E dot B divided by mod A. So now let's calculate each of these. So let's go back here and see from this what is our A dot B. A dot B is 2 plus 2 plus 4, correct? So it is 8. And mod A 2 into 1 plus 2 into 1 plus 2 into 2. Okay, so, and mod is root of 1 plus 4 plus 4, so that is 3. So this becomes how much? It becomes 8 by 3. Okay. And A cap is vector A divided by mod A. So it is I cap plus 2j cap plus 2k cap divided by its own magnitude, which is 3. So now we can just do the algebra here. So B's parallel component is B cos theta, which is this much, into A cap, which is this much. Just confirm once. Okay. So that will become 8 by 9 into this. So 8 by 9 I cap plus 16 by 9 j cap plus 16 by 9 k cap, or we can also write it as 8 by 9 common, so I cap plus 2j cap plus. So any of these answers is okay, but this becomes a component parallel. Okay. So this is your final question of the first exercise. So few questions I haven't discussed, but I think you can handle them. Okay. If you have any difficulty with any other questions of exercise 1, please send me a message and I'll help you out with the doubt part of it. Okay. So with this we conclude today's lecture. Now next lecture we will be looking at, as I wanted to discuss few things actually. So next lecture we will be looking at some more questions of vectors, but we'll also be looking at introductive start to Newton's laws of motion. So next session will involve more problems in vectors plus introduction to Newton's laws of motion. So now that we are coming to Newton's laws of motion, I'd like to discuss about some reference books that you can follow. For physics. So one is obviously you'll follow the module of IITian sub. Now, along with this, you can also follow this book, Concepts of Physics. Okay. Part 1 and 2. This will cover both class 11 and 12. By Dr. H.C. Verma. So these are 2 compulsory materials you can follow, and I'll inform you about the syllabus in time. Don't worry. Okay? Additional reference for JEE Advanced level physics. We'll inform about the test and all, don't worry. So additional reference material for test will be, for JEE Advanced Physics will be Physics by Resnick Halliday and Green. This is for theory only. And you can also follow Mechanics 1 and 2, which is part of the Arihant publication series. For JEE Advanced, okay, by DC Pandey. So this is for additional practice problems only, not for theory. Okay. So this additional reference material is optional, not compulsory. You can get it at a different stage also. When you are doing revision later also, you can refer to this. But this part is compulsory. Yeah, this for class 11. In 12th, there will be more series. Okay, this will cover 11th and 12th. This is only for 11th. In 12th, there will be electromagnetism, current, electricity, things like that, other chapters. Okay, so this is a bigger series of books. There is a total of 6 books. So out of that, these 2 you can start with. In fact, right now, there will be Mechanics 1 only. Only after 3 or 4 months, we will come to Mechanics 2. Alright, so this is about the reference books. I'll be sending you the whiteboard so you can get hold of the names from that. So try to complete exercise 2, 3, and 4 of the worksheet now, of the module now, and wind up vectors so that next time we can finish off the discussion of few more problems and start with an introduction of Newton's laws. Okay, so that's it from my end today, guys. All the best.